October 1968. Naval Facility Point Sur, California. Outside, the Pacific Ocean crashes against the cliffs, a chaotic wall of white noise. Inside the windowless concrete bunker, the air is still. It smells of stale coffee, ozone, and cigarette smoke. A technician sits before a wall of electronics, headphones pressing tight against his ears. He is listening to the bottom of the world. His job is monotony. He watches a stylus trace lines on a rolling sheet of thermal paper. He listens for the specific mechanical signature of Soviet diesel-electric submarines, the rhythmic thrum, thrum, thrum of a propeller shaft, or the whine of a carelessly maintained cooling pump. But at 300 hours, the stylus jumps. It isn't a submarine. It isn't a whale. It isn't the grinding tectonic groan of the earth shifting. The sound is loud. It registers across the entire low-frequency spectrum. It doesn't fade like a passing ship. It lingers. It suggests mass. It suggests deliberate movement. The technician marks the timestamp. He flags the tape. He calls the watch officer. They listen together. They check the classified catalogs of known acoustic signatures. They check the logs of U.S. naval movement. They check for registered seismic activity. Nothing matches. This was not an isolated incident. For 40 years, beneath the geopolitical standoff of the Cold War, a second silent history was being recorded. In the blind depths of the Atlantic, the Pacific, and the Arctic, the superpowers were listening, and frequently what they heard defied explanation. These are the recordings that didn't fit the narrative, the anomalies, the sounds that made intelligence officers question what, exactly, was sharing the ocean with them. To understand the significance of these recordings, one must understand the environment in which they were captured. By the mid-1960s, the ocean was no longer a wilderness. It was a battlefield wired for sound. The United States had constructed SOSUS, the Sound Surveillance System. It was a chain of massive hydrophone arrays anchored to the continental shelves and deep ocean floors. These underwater microphones were connected by thousands of miles of cable-to-shore stations, creating an acoustic tripwire designed to detect Soviet submarines leaving their bases in Murmansk or Vladivostok. Sound is the only reliable data in the deep. Light penetrates only a few hundred feet. Radar stops at the surface. But sound? In the right thermal layer, the deep sound channel, a low-frequency noise can travel thousands of miles without losing its energy. The Soviets, too, were listening. Their trawlers dragged hydrophone arrays, and their submarines were equipped with sophisticated sonar suites. Both sides were building a library of the ocean's acoustic profile. They catalogued everything: the chattering of shrimp, the songs of blue whales, the cracking of ice, the rumble of underwater volcanoes. The goal was elimination. If a sound could be identified as biology or geology, it could be ignored. If it was mechanical, it was a target. But as the sensitivity of the equipment improved, the number of unidentified transients, short, unexplained sounds, began to rise. Analysts were trained to be skeptics. They were engineers and physicists. They did not believe in sea monsters. They were looking for titanium hulls, cavitation bubbles, and active sonar pings. Yet, the classified archives began to fill with tapes that fit none of these categories. In the mid-1970s, a SOSUS array in the North Atlantic picked up a signature that became a persistent subject of debate within naval intelligence. It was located near the Mid-Atlantic Ridge, a volatile zone of seafloor spreading. Analysts were used to the sounds of the earth moving, violent, sharp cracks or low, rumbling tremors. This was different. The recording captured a sound best described as heavy friction. It was the sound of metal, or something with the acoustic density of metal, being dragged across the basalt of the ocean floor. But the scale was impossible. Based on the triangulation of the hydrophones, the source of the noise was moving. And it was moving continuously for hours. A geological event, like a landslide, is chaotic and finite. It crashes, rumbles, and stops. This sound had a cadence. It paused, then resumed. It maintained a steady bearing. Intelligence officers immediately suspected a new Soviet technology. Was it a seabed crawler? a device designed to cut transatlantic communication cables? The Soviet Union had a known interest in deep-sea engineering, but the logistics of dragging a massive construct across the jagged terrain of the mid-Atlantic ridge at that depth were technically staggering. There was no engine noise associated with the drag, no cavitation from propellers, just the grinding rhythmic scrape. The file remained open. No Soviet surface ships were in the area to deploy such a device. No submarines were tracked on the sensors. The sound simply started, continued for 6 hours, and then ceased as if the object had been lifted or had stopped moving. To the analysts, the metal drag was a source of profound frustration. It implied a capability that shouldn't exist, operating in a domain that should have been accessible only to bathyscaphs, not heavy industrial machinery. While the Atlantic is a busy corridor of commerce and war, the Pacific is a void. Its depths are greater, its silence more profound. In the late summer of 1981, hydrophones across the Pacific Basin, from the Aleutian Islands to the coast of California, detected a signal of immense power. It was not a transient click or a bang, it was a long, descending frequency sweep. In the civilian scientific community, similar sounds, like the famous bloop or Julia, are often attributed to ice calving, massive icebergs scraping the seafloor or fracturing in Antarctica. But for the military analysts of 1981, ice was an insufficient explanation for the specific characteristics of this signal. The frequency drop was smooth, too smooth. Ice fractures are jagged, they pop and crackle. This sound descended in pitch with a mathematical precision that unnerved the listeners. It mimicked the acoustic behavior of a machine slowing down, a massive turbine winding down to a halt. But the physics didn't make sense. For a biological source to create a sound of that volume and frequency depth, the creature would need to be significantly larger than a blue whale, with a physiology unknown to science. The Navy dismissed biology. The focus turned to the Soviets. Was this the acoustic signature of a new propulsion system? A magneto-hydrodynamic drive being tested in the deep Pacific, far from prying eyes? The terrifying aspect of the frequency drop was the range. The sound was loud enough to be detected by sensors separated by thousands of miles. If this was a machine, the energy required to generate that sound wave was enormous. The recording was analyzed, filtered, and sped up. At higher speeds, it didn't sound like ice. It sounded like a synthetic tone. The event was never repeated. Whatever generated that signal in the summer of 1981 did it once, and then vanished into the background noise of the ocean. The confusion was not one-sided. The Soviet Navy, with its northern fleet based in Severomorsk, guarded the Barents Sea with paranoia. This was their backyard, the bastion where they hid their nuclear-armed submarines under the Arctic ice. Declassified accounts from Soviet sonar operators describe a recurring phenomenon in the late 1970s and early 1980s. They called it the pulse. It was a rhythmic, percussive beat, precise, mechanical. One beat every 2 seconds. Soviet captains initially assumed it was American. They believed they were being tracked by a new class of U.S. attack submarine using an exotic form of active sonar, a banger device meant to intimidate or locate them. They would execute evasive maneuvers, dive deep, or run silent. But the Americans were hearing it too. NATO recordings from the Norwegian Sea captured the same rhythmic pulse. U.S. intelligence reports hypothesized it was a Soviet underwater navigation beacon, a lighthouse of sound, to help their subs navigate without surfacing. Here lies the irony of the Cold War. Both sides were listening to the same sound, and both sides were convinced it was a secret weapon belonging to the enemy. When the Iron Curtain fell and records were compared, the truth proved more unsettling. The Americans hadn't built it. The Soviets hadn't built it. The pulse was stationary, yet it seemed to appear in different sectors of the Arctic. It did not move like a ship. It did not drift like ice. It simply was. Some theories suggest expansive gas vents releasing bubbles in a rhythmic cycle. Others suggest a specific type of geological resonance. But to the men wearing the headphones, huddled in the freezing steel bellies of their submarines, it didn't sound like mud or gas. It sounded like a clock, ticking down in the dark. Perhaps the most documented and tactically alarming of these mysteries was the phenomenon known as quackers, or to the Soviets, the frog. Encountered primarily in the North Atlantic and the Norwegian Sea during the 1970s and 80s, these weren't just distant noises. These were contact events. Submarine crews would report a sound similar to the croaking of a frog, but metallic and amplified. But the sound wasn't the issue. The behavior was. Sonar operators tracked these sources moving at speeds in excess of 150 knots. In the 1970s, the fastest torpedoes topped out at 40 or 50 knots. The fastest submarines struggled to reach 40. Physics dictates that moving through water at that speed creates a massive resistance and noise. Yet these quackers would streak across the sonar displays, circle a NATO or Soviet vessel, and then vanish. The Swedish Navy, hunting for suspected Soviet intruders in their archipelago, frequently encountered these signatures. They fired depth charges, they deployed mines, they never hit anything. If it was a Soviet weapon, it defied the laws of fluid dynamics known at the time. Supercavitation technology, which encases a torpedo in a gas bubble to reduce drag, was only in its infancy. If it was biological, it was a creature that swam at highway speeds and emitted metallic croaks. The incidents were so frequent that they became a normalized anomaly. Captains would note quacker contact in the log and move on. It was a threat they couldn't engage, a target they couldn't classify. It became a ghost in the machine, a distinct acoustic reality that the military simply learned to ignore because they couldn't explain it. The true tension of these recordings lies not in what they were, but in what they represented to the people listening. In the Cold War, uncertainty was dangerous. A sound that couldn't be identified was a gap in the armor. It was a potential first strike weapon, a new surveillance drone, or a silent killer waiting to be deployed. The analysts who spent their lives in windowless rooms, listening to the static of the deep, were tasked with imposing order on a chaotic environment. They had to sort the ocean into two piles, nature and threat. But the ocean refused to be easily sorted. These recordings, the metal drags, the frequency drops, the impossible speeds, fell into the gray area between the piles. They were alarming because they sounded engineered. They had rhythm, structure, and consistency. They mimicked the creations of man, yet they exceeded the capabilities of the era. They forced the military to confront a quiet, uncomfortable truth. That despite the billions of dollars spent on surveillance, despite the hydrophones draping the continental shelves like spiderwebs, the ocean remained largely opaque. The Cold War ended. The Soviet Union collapsed. The SOSUS networks were largely declassified or repurposed for scientific research, used now to track whale migration and undersea volcanoes. Many of the sounds that terrified intelligence officers were eventually explained. Some were ice, some were uncharted seismic vents, some were undiscovered species of whale, finally identified by marine biologists years later, but not all. There are tapes in the archives of the US Navy and the Russian Federation that remain classified or simply unmarked. Loops of magnetic tape capturing sounds that have no name. We went to the ocean looking for the enemy. We filled the water with our fears, expecting to hear the machinery of war. Sometimes we found it, but sometimes the ocean spoke back in a language we still do not understand. And in the silence of the deep, long after the listening stations have been powered down, those echoes remain.